Mount Etna has erupted again, but this time, something's different. Something no one was expecting. A glowing, luminous substance is oozing out alongside the lava flows, and here's the kicker: scientists have never seen anything like it. No historical record, no prior observation, no textbook entry. This isn't your typical volcanic activity, it's a full-blown geological mystery unfolding in real time. Right now, the world's volcanologists are scrambling. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one. What is this strange material? How did it form? And what does it mean for our understanding of how volcanoes even work? For now, there are no clear answers, only growing questions. The only certainty: whatever just emerged from Mount Etna, it's something new, and that should concern everyone paying attention. The event started with the paroxysm, one of those explosive, short-lived bursts that Mount Etna is infamous for. Think of it as the volcanic equivalent of a tantrum: sudden, violent, and intense. But this time, that tantrum triggered a pyroclastic flow that ripped through the eastern flank of the volcano. A fast-moving surge of gas, ash, and rock, crashing down in seconds, carving straight through an ancient basin known as the Val del Bo. Now, Val del Bo isn't just a scenic crater. It's the remnant of a catastrophic landslide from long ago, one that caused a tsunami so massive it made it into geological memory. And now, thanks to Etna's most recent outburst, that same valley is being reshaped yet again. This time, by the most aggressive type of volcanic activity you can get outside of a full eruption: pyroclastic devastation. The landscape is shifting before our eyes. So, what do we know about Mount Etna that could explain this? Not much, honestly, and that's the point. Etna is one of the most studied volcanoes in the world, but it's also one of the most complex. That complexity comes from its geochemistry. Etna's magma isn't coming from a single, tidy source. It's a hybrid, a cocktail of deep mantle material and crustal elements stirred together by tectonic forces grinding beneath the surface. That mash-up creates unpredictable eruptions and strange chemical outcomes. But even with that complexity, nothing in Etna's eruptive history has produced a material like what's currently being seen, which makes this a turning point for volcanology. If the source of the luminous substance is coming from even deeper inside the Earth than previously thought, we could be looking at a window into entirely new geochemical processes, possibly even something that hints at previously undiscovered layers or reactions in the mantle. And let's not overlook how dangerous this eruption was. That pyroclastic flow wasn't just a footnote, it was one of the fastest, most violent events we've seen on Etna's slopes in years. A 3-kilometer path was ripped open almost instantly, transforming stable ground into a deadly terrain. The only reason there were no casualties? Strict emergency protocols kept visitors and researchers at a distance. If that hadn't happened, this would be a very different story. Etna's recent activity also serves as a reminder of the volcano's structural instability. The combination of strombolian eruptions, those rhythmic, small explosions with the sudden pyroclastic burst, suggests that something went seriously wrong inside the vent. When those two types of activity collide, it's usually a sign that the magma chamber is under extreme stress. Pressure is building, and when it finds a release, from Mount Erebus in Antarctica to Iceland's Hekla volcano, Earth's volcanic systems are essentially giant mineral delivery systems. Oregon's McDermott caldera, for instance, is one of the richest rare earth element deposits in the U.S. These places aren't just geological curiosities, they're economic engines. Without them, entire industries would collapse. Even underwater volcanoes get in on the action. Submarine hydrothermal vents spew out mineral-rich fluids that solidify into ore deposits: copper, zinc, sulfur. It's like an underwater mining operation that runs 24/7 without anyone touching it. And as more research is done, scientists are realizing these ocean floor volcanoes may hold even more untapped resources than we previously imagined. But it's not just about treasure. Volcanic minerals also play a critical role in agriculture and industrial production. Feldspar, olivine, pyroxene, biotite. These are more than just pretty names for rock nerds. They carry titanium, iron, and sulfur. They enrich soils. They form the base of building materials. Without volcanoes, the ground we walk on would be poorer, literally and figuratively. Back to Etna. The fact that it's emitting a mystery substance adds another layer to this mineral narrative. If this material turns out to contain rare elements, or if it indicates a new mineralization process. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one. It could open up entirely new areas of study. Scientists are already talking about deploying drones and remote sampling equipment to safely analyze the material, since direct access is far too dangerous. That danger can't be overstated. Lava lakes can reach temperatures above 1,000 C. Toxic gases like sulfur dioxide blanket the area. The terrain is shifting constantly. No human or current robot can survive long enough inside an active lava zone to collect samples the old-fashioned way. It's a logistical nightmare. That's why drone tech is becoming so vital to volcano research. It's the only way to peek inside without risking lives. But all of this research Etna, Arabis, McDermott, Oldoinio Lingai in Tanzania feeds into something even bigger. Understanding planetary geology. Volcanoes on Earth are giving scientists clues about what might be happening on other planets and moons. Antarctica's Mount Erebus, with its extreme cold and isolated conditions, offers a glimpse into how cryovolcanism might work on icy bodies like Europa or Enceladus. Those moons may have subsurface oceans and volcanic-like activity that could one day tell us whether life exists beyond Earth. So, yes, Mount Etna just blew up in a new and terrifying way. Yes, it spewed out something that no one can identify. But in the chaos lies opportunity, scientific opportunity, economic opportunity, even planetary exploration opportunity. Volcanic activity is messy and violent, but it's also the reason Earth has the resources it does. The diamonds, the gold, the rare earths, they all come from this cycle of destruction and creation. And even though we can't mine lava lakes or dive into magma chambers yet, the path forward is clear. Smarter technology, remote sensing, safer sampling methods, that's where the future of volcanology lies. And with every strange eruption, like Etna's latest, we're getting closer to unlocking those underground secrets. So what now? Scientists are waiting, watching, gathering every shred of data they can. Because whatever that luminous material is, it could change what we think we know about Earth's interior. It might rewrite the rules of volcanic behavior. And it might just be the first sign of a deeper, more powerful process we've never understood until now. If you're as stunned by Mount Etna's latest eruption as we are, drop a comment and tell us what you think that mystery substance could be. Don't forget to like this video, share it with your fellow disaster nerds, and hit subscribe for more volcanic drama, geological weirdness, and science stories that shake the ground beneath your feet. And here's where things get even stranger. That mysterious, luminous substance? It didn't just appear during the eruption, it persisted. Flowing alongside the molten lava, it held its glow, visible even in daylight. Scientists watching live feeds and drone footage couldn't believe their eyes. This wasn't a fluke or a trick of the light. It was something real, tangible, and entirely undocumented in the history of Mount Etna or any volcano, for that matter. You have to understand, Mount Etna isn't some obscure volcanic cone in a remote jungle. This is Europe's most active volcano. It's been studied to death. We know its patterns. We've cataloged its rock types, gas emissions, seismic history. It's erupted hundreds of times. And yet, this has never happened before. That's what makes it so alarming. Some experts are speculating that the strange emission might be a signal from deep within the Earth, an indication that we're finally accessing materials from zones far below the crust, places we've never sampled, not even with our most advanced drilling systems. If that's true, it means we're seeing a geochemical process unfolding in real time that science has literally never witnessed. It's not just new for Etna, it's new for Earth. And while that sounds thrilling, it's also unsettling. Because if the rules of volcanic behavior are starting to shift, what else are we underestimating? The timing of this event is significant too. Etna's recent eruptions have been increasingly erratic, with new vents opening up in unpredictable places and magma composition becoming more diverse. It's not just about heat and pressure anymore, it's about instability, structural, chemical, and maybe even tectonic. And if the underlying geology is changing, the risks multiply. That includes more frequent eruptions, unexpected vent locations, and increased danger to nearby populations. Now, thankfully, this latest event didn't result in casualties. That's because Italy's volcanic monitoring system kicked in fast. Local authorities had already closed off visitor areas ahead of time. Scientists were watching the signs: tremors, gas spikes, minor lava fountaining. They knew something was coming. But even they didn't expect this level of force, or whatever that glowing material was. What they did expect, however, was the violent paroxysm that triggered the pyroclastic flow. Etna has a long history of these explosive mini-eruptions. They're fast, brutal, and leave little time for reaction. Pyroclastic flows, specifically, are one of the deadliest forms of volcanic activity, not just because of their speed, but because of their heat and suffocating gases. Survivability. Near zero. This one tore through the eastern flank and cascaded down into Val del Bo, a basin formed long ago by a historic landslide so massive it generated a tsunami. Think about that, a mountain falling into itself with enough force to move the ocean. That's the scale of destruction Etna has played with before. And now, with the terrain destabilized yet again, who knows what geological chain reactions could follow. But let's zoom out for a second. Because while the drama is centered on Etna, the implications stretch globally. This isn't just about one eruption. It's about what volcanoes tell us about Earth's inner workings and what they give us in the process. Volcanoes are like pressure valves for the planet. And every time one erupts, it doesn't just spew lava, it delivers buried treasures. Literally. Gold, diamonds, rubies, platinum. These don't just sit around waiting to be mined. They're forged in the crushing heat and pressure of Earth's mantle, and without volcanic activity to bring them up, we'd never see them. That engagement ring, that smartphone battery, that high-speed electric motor, all possible thanks to volcanoes. Take Tanzania's Ol Doinyo Lingai, for example. It produces nitrocarbonatite lava, one of the rarest types in the world. It's cold enough to touch within hours of erupting, and it's loaded with rare earth elements, materials essential for modern technology. That's right, the same forces that can bury cities also build the future of green energy and tech. Or look at Siberia's kimberlite pipes, ancient volcanic formations that deliver diamonds straight from the mantle to the surface. These aren't just rocks, they're billion-dollar industries formed by explosive geological violence. The same pattern repeats across the globe. Iceland's volcanic systems give us geothermal energy. Antarctica's Mount Erebus sits on mineral-rich deposits that could rival anything above ground if we could ever get to them. And don't even get started on underwater volcanoes. Submarine hydrothermal vents are quietly producing vast fields of valuable minerals at the bottom of the ocean. Sulfides, copper, zinc, industrial gold mines, just out of reach. The problem? We can't get there safely or sustainably. The temperatures are extreme, the ecosystem's fragile, and the technology still catching up. That's the double-edged sword of volcanism. It holds everything we need, but getting to it could kill you. The terrain is unstable. Toxic gases fill the air. Temperatures melt equipment. Lava lakes can swallow drones. Even robotic extraction is, for now, science fiction. That's why the Lehir mine in Papua New Guinea is such an anomaly. It taps geothermal fluids to extract gold clean, contained, and shockingly effective. But it's the exception, not the rule. Most volcanic systems are still too hostile to harvest directly, which means we're stuck waiting, watching, and studying from a distance. And right now, all eyes are on Mount Etna. This eruption, bizarre as it is, could be a turning point not just in terms of geological understanding, but in how we think about Earth's resources, our ability to study them, and our relationship with natural forces we don't control. Because let's be honest, there's something deeply humbling about a mountain suddenly spitting out a material no one can identify. It's a reminder that we're still guests on this planet. The Earth is older, deeper, and more complex than we can fathom, and every once in a while, it reminds us who's really in charge. Volcanoes are part of that reminder. They're the planet's storytellers. Every eruption is a message from the deep, and sometimes, those messages are louder, stranger, and more glowing than anything we've seen before. So now, the race is on. Scientists are rushing to sample whatever they can using drones, remote sensors, anything that can survive the brutal conditions on Etna's slopes. Labs around the world are preparing for analysis. Geochemists are already speculating on rare mineral content, exotic compounds, maybe even entirely new elements formed under mantle conditions we've never replicated in labs. But it all hinges on one thing: unlocking the mystery of that luminous material. Is it radioactive? Is it rich in metals? Is it signaling a deeper shift in tectonic behavior? Or is it just the first visual evidence of a process that's been happening beneath our feet, all along quietly, invisibly, until now? The truth is, we don't know yet, and that uncertainty is both exciting and unnerving. Because if Mount Etna can throw us this kind of curveball, what else is out there waiting to be discovered? Volcanoes are dangerous, yes, but they're also essential. They're the source of so much of our planet's beauty, danger, and wealth. They give us the minerals that power civilization, the landscapes we marvel at, and now, apparently, glowing substances that break all the rules. So keep your eyes on the lava, because whatever's coming out of Mount Etna, it's rewriting the playbook. And as the smoke settles, at least for now, one question lingers louder than the rest. How did we miss this? How, after decades of monitoring, drilling, scanning, and mapping Mount Etna down to its bones, does a glowing, unidentified substance suddenly ooze out like it's been hiding in plain sight? What else is the Earth holding back? This isn't just some exotic quirk of lava composition. It's a full-blown scientific disruption. It challenges our assumptions about what magma chambers are made of, what reactions can occur under ultra-high pressures, and what volatile materials might be locked away in the deep mantle, waiting for their moment. We're not talking about a subtle change in ash color or a slightly different gas ratio. We're talking about something so out of bounds that geologists are using words like unprecedented, unexplainable, and the ever-ominous, never before seen. And let's be real, never before seen is not a phrase scientists throw around lightly, especially when it involves a volcano that's been erupting for hundreds of thousands of years. Etna isn't new to the game, but what it just did, that is. And now, the floodgates are open. Geological research institutions are forming new task forces. Remote sensing projects are being fast-tracked. Mineralogists, chemists, and volcanologists are all circling the same big unknown. What is this stuff, and what does it mean? Because if this glowing material turns out to be a sign of deeper mantle activity, some exotic compound formed under conditions we've never been able to replicate, then Etna might not just be Europe's most active volcano. It might be our first real access point to parts of the Earth we've only theorized about. So keep watching, because whatever Mount Etna just unleashed, it's not over. It's only the beginning of a story that might reshape how we understand the planet beneath our feet. If this eruption shook your sense of what's possible, drop a comment below. Tell us what you think scientists are going to find in that glowing flow. And don't forget to like, share, and subscribe, because the Earth just turned the page, and we're reading it with you, line by glowing line.